Hello, Nutrition 160 students, and welcome to Chapter 8, Energy Balance and Body Composition. So let's begin with some simple terms regarding energy balance. As you see here in the image depicted, a lot of you have heard the term energy in equals energy out, and you're stable, and you're not gaining weight, and you're also not losing weight, but rather maintaining. And if you want to lose weight, you probably heard that you have to make sure that your calories in are less than what you are expending out. Okay, so expending more out and less in. So these simplistic mathematical concepts. Now, I do want to say that that is true to some extent, that calories in equals calories out. However, you will learn in this chapter that we have something called basal metabolic rate, and that is the mere calories needed to keep you alive. So just to keep your heartbeat regulated, your nerve impulses going, just sustaining your systems in general and your human physiology and biology. So just being alive requires some energy. So if you were to expend all your calories out that you eat from your diet in order to lose weight, you would also be wreaking havoc on some of your biological functions and processes, okay? So excess energy stored as fat, fat used for energy between meals. So I do want you to know that for a lot of you who maybe miss meals or fast, a lot of the stored fat in your body is used to fuel you while you're fasting until your meal comes. So again, survival mode. Energy balance, again, energy in equals energy out. Again, I told you some of that out should also incorporate what you're expelling out, not just through physical activity, but through just living that basal metabolic rate, those calories needed to just merely keep you alive. And there's basic biological functions that occur, like breathing, heartbeat regulation, and so on. An imbalance causes weight changes, not simply fat changes. You can also lose water weight. You can lose muscle weight as well. And you can also gain those that I just explained as well. The classic rule, I do want you to know is that a pound of fat equals 3,500 calories. So you'd have to make some deficits daily around this 3,500 calories. And usually those daily deficits in calories can equal 3,500 calories in a week, and progressively over time you can lose weight. Now again, there's limitations based on gender and weight. I do want you to know that women are genetics. We stature-wise, we do carry more fat in general because of functions and roles that we have, such as bearing kids and so on. And men tend to have genetically less fat in their genetic structures and have more muscle mass than us because they are genetically more muscular than us, and they're just made that way with a little bit more muscle and also more water compartments genetically. You can alter those things that I just explained. Those are just general genetic traits, man versus woman. But again, you can alter those through living lifestyle factors. But just those are some things that you should consider. So here is a little matching exercise that you can do on your own at home. You can pause the lecture and work on it and test your knowledge and pretend that you're taking the exam just to test your knowledge. It's always good to do that. And then you can replay it and then come back to the answers. So you can pause it right now if you want to do that, and then come back. And here are the answers. So A, hunger, the answer is D. Hunger is a physiological response triggered primarily by the hypothalamus, which is a region in the brain, to want to eat. And a cascade of hormones is also driven by this response. Now B has two answers. It's A and E. So satiety means a feeling of fullness occurring after a meal and determines how much time passes between meals. So if you've ever eaten a meal and you are full, really, really full, you can say that you have experienced satiety. So satiety not only means you're something that you feel full after you've consumed a meal, But it also determines how long you will eat, or how that feeling of fullness, how long will it last before it is triggered to eat another meal. So it's that timeline between one meal and the next meal. And C, satiation, it's a little different. That one's B and C. So satiation is a feeling of fullness that you feel during a meal. So if you ever were served a meal and you could not finish it, and you just felt full a little sooner than you thought, you're feeling satiation. It's during a meal. And also C, so it determines how much food is consumed during a meal. So when we're talking about feeling full during a meal and how to eat during a meal so we don't eat too many calories, and what are factors that influence feeling full, like drinking water, eating a high fiber diet, eating protein during a meal to get that feeling of fullness sooner, that is satiation. So that one occurs, satiation, the difference between satiety and satiation. Satiety occurs after a meal, and then how long it will take you to eat your next meal, how that feeling of fullness lasts. And satiation means how fast do you get full during a meal. And a lot of factors determine that, again, such as protein, fiber, and other substances you might be ingesting, and also mood things. Hunger, satiation, and satiety are triggered and influenced by many things. They can be triggered by physiological influences. For instance, are you on an empty stomach? Certain hormones, gastric contractions, the absence of nutrients in the small intestines, certain endorphins in the brain that trigger smell, sight, or taste, can physiologically influence what you eat. Sensory things as well, like the thought, sight, and sound and taste of certain food. Other things are involved, like cognitive influences, which include social stimulation. So some of us tend to eat certain things that we normally wouldn't eat given a certain social setting. Things like nostalgia as well can influence. So like, for instance, some of you might eat certain meals associated with your childhood because it gives you a good feeling. And then there's other things that can affect hunger, satiation, and satiety. Like certain nutrients that can influence that when they're eaten together, how they interact and influence this feeling of fullness. For instance, fiber has been shown to increase fullness during a meal and trigger the brain that you're full. Some people drink a glass of water prior to eating because that glass of water is in the stomach, and it has this pre-signaling to the brain that we're full, and it allows us to eat less calories when we are eating. Factors that influence eating, overriding hunger and satiety. So boredom, anxious, and stress. Okay, some of us maybe eat because we're bored. Maybe it could be happening right now during this transition due to the pandemic. Maybe because you're anxious or you experience some kind of stressor. External cues have a lot to do too. For instance, I'm not a big breakfast person. It takes me quite a long time to wake up, so I tend to eat breakfast a little later, and I don't have an appetite till a little later, like around 9 or 10 a.m. Availability of foods, the sight and taste as well. Environmental influences, which can also include things like your social stimulus. Cognitive influences, also part of social. Again, your cognitive influences change depending on what social environment you're in. Environmental influences can also include the time and place that you're at. For example, and also events and who you live with. Many things fall into that category. We're going to talk about disordered eating. I have a lecture on eating disorders that is paired with this lecture as part 2. But I want you to know that some disordered eating doesn't mean you have an eating disorder, but it can lead to, it can be a precursor to an eating disorder is what I'm trying to say. So when we talk about what can we eat that is most satiating during a meal, protein has been proven to be the most satiating nutrient, along with fiber. I want to add that. Low energy dense foods, high fiber foods, which are mainly your fruits, vegetables, and whole grains, tend to be high in fiber as well. And high fat foods can also signal strong satiety signals. Satiety is more after a meal and between meals. So Foods that have a little bit more fat during the meal have been known to help you feel fuller for a longer time before you eat again. And then certain hormones as well. The hypothalamus, again, is a small region in the brain. It's a control center for eating. It integrates nerve and hormonal messages. List and explain three main components of energy expenditure by the body. Okay, so you can do this on your own, but I provided it for you. So three main components of energy expenditure by the body. You can expend energy or calories through basal metabolism. And again, basal metabolism is the calories or energy needed to merely keep you alive and functioning as a healthy, normal individual. Basal metabolism accounts for activities to keep the body functioning, varies based on weight, lean tissue, and age. And stature. Bigger people require more calories than smaller people to keep them alive. Physical activity is another way to expend body. Voluntary muscular movement. This is the most variable and readily influenced component. Weight, lean muscle, and the type of activity impact the amount of energy needed. I also want you to know that there's something called the thermal effect of food, which accounts for some calorie expenditure, and that's the amount of energy needed to digest, absorb, transport, store, and metabolize food. So yes, in order to process food that you eat from, nutrients that you eat from food, these substances, that requires energy. And it accounts for about 10% of the energy intake. It varies again based on meal frequency, size, and macronutrient composition. Adaptive thermogenesis. So when you hear this term, it refers to how our body adapts to dramatically changing circumstances. And an example is cold environments. So when we are cold, we shiver. That's an adaptive thermogenesis mechanism. So shivering is an example of how our body adapts to certain environmental cues in order to keep us functioning normal. Hibernating animals and babies have something in common as well. They don't have the ability to shiver. So their adaptive thermogenesis is something that they have is called brown fat. And it's called brown fat because it's brown. And believe it or not, infants do not have the ability to shiver. They haven't developed that involuntary response yet. So they have something called brown fat, which is the same thing that bears and other hibernating animals have. And this brown fat is brown because it's very rich in mitochondria. And mitochondria, again, is that organelle in cells responsible for generating energy. And also it's high and rich in blood. And that's what gives brown fat the dark appearance, is the abundant amount of mitochondria in that red, rich color from the blood. And it's active fat, and it keeps infants and hibernating animals warm. Extra work done by the body, the amount expended is extremely variable depending on your daily task and your exercise regimen. It's not included in energy requirement calculations. There are calculations that you can do that take into account your physical activity, but just know that a lot of the adaptive thermogenesis calculations that are out there only account for things that are meant to merely keep you functioning as an individual and going through your daily tasks, and not those physical activity, or to be more just to be a little bit more descriptive, because I am a kinesiology major, that's my undergrad. There is a difference between physical activity and exercise. Physical activity is just mere muscular movement, and it could be anything from like walking from your car, going to the grocery store. That's physical activity because you're moving your muscles, whereas exercise is considered more of a structured type of physical activity, and it has intentional components such as like reps, volume, frequency, duration, and so on. It gets a little bit more scientific. Okay, so I just want you to know that. Components of energy expenditure. So I want you to know that when we talk about what calories, and you want to know what accounts for our calories or energy expenditure, it's not just exercise. As you see here in this pie chart, it says that the amount of energy expended in a day differs for each individual. But in general, for everyone, basal metabolism, as you see here, 50 to 65% of our calories goes to basal metabolism, is the largest component of energy expenditure, and the thermic effect of food is the smallest. And physical activity accounts for 30 to 50% of our calories. Okay, so this is straight from your book. Make sure you understand it, but I can ask you on the test, about energy expenditure, what accounts for most of the calories out, and that would be our basal metabolism. And then physical activity would be second, and thermal effect of food third. And if I ask you which one of these is the most variable, it would be physical activity. So estimating energy requirements. So when we estimate energy requirements, there are some, we call them EER, Energy Estimated Requirement Charts. And they're very general, based on your age and your gender. It tells you how many calories approximately are estimated you need a day just to keep you healthy and to maintain your weight. And then there's more complicated charts in which you can find out based on how much you jog a day. Like if you jog an hour a day, it tells you like you expend about 500 calories, at this certain speed of jogging. And you can also account that for your energy expenditure or your energy requirements. So it can get quite complicated. You can start using a lot of charts. But when we estimate your energy requirements, we look at gender, growth. Are you experiencing a growth spurt? Are you a child? Are you a growing teenager? Are you an athlete who is in an anabolic state and you're wanting to gain muscle? Your age as well. There's changes with age. Physical activity, how active you are, and any body composition goals you might have. And body composition and body size and height and weight factors also account for how much you need. For example, if you're a woman here, if you're 5'0", 5 feet tall, and you weigh 110 pounds, just to maintain your weight, you need less calories than someone that is like 6 feet tall and is 5'11". Tips for accepting a healthy body weight. So I will be asking you what are some things that you can recommend for people in order to accept a healthy body weight. And here are some things straight from your book. Value yourself and others for human attributes other than body. Body weight, kind of weight's supposed to be up. One, realize that prejudging people by weight is as harmful as prejudging them by race, religion, or gender. That is very important. I actually thought about that many years ago. I thought that, criticizing or someone for their body size came from the same hateful place almost as people that don't like certain humans based on race. Use positive, non-judgmental descriptions of your body. Accept positive comments from others. I know that it's taken me some time to do that. Focus on your whole self, including your intelligence, your social grace, and professional and scholastic achievements. And I would also want to add that check your associations, because who you associate with can also help or wreak havoc on your body image. Accept that no magic diet exists. Stop dieting to lose weight. Adopt a lifestyle of healthy eating and physical activity permanently. Follow the United States Department of Agricultural food patterns. Never restrict food intake below the minimum levels that meet nutrient needs. Become physically active, not because it will help you get thin, but because it will make you feel good and improve your health. Okay, and there's a huge fitness revolution going on right now on social media. You can find all kinds of workouts and all kinds of personalities and shapes of trainers and people on social media. Okay, but make sure you check their credentials as well. You can seek support from loved ones, tell them of your plan for a healthy life, or for some instance, some family members might not be supportive. You can also always find social media groups. Sometimes there's certain groups that meet in the community. You can start your own group. You can make new friends. There's so many communities out there, not just in your own neighborhoods, but online to help you. You can seek professional counseling from someone who can help you make gains in self-esteem without weight as the primary focus, and appreciate body weight for its influence on health and not appearance. Let's talk about body mass index. A lot of you have heard about a tool called BMI or body mass index, and some of you have good perspectives about it, and some of you have bad perspectives or negative perspectives. A good way to use BMI is to not use it alone. If you use BMI or body mass index alone to determine someone's health status, that is not a very good way to use this tool. A good way to use body mass index is to use it along with other fitness, health, and diet tools and assessments. So it should be part of an overall profile of someone, but it should also not be used alone to assess someone's health. You should also not ignore what it tells you. For example, a bodybuilder, a professional elite bodybuilder, is extremely muscular with little fat, almost at 0%. When they're peaked, they would be considered obese on the BMI based on height and weight, because BMI is based off of height and weight. So a lot of bodybuilders that I ran into have said, I don't care about BMI because it doesn't tell me how much muscle and fat I have. It just merely says I'm obese based on my height and weight. However, they should not ignore what it's telling them, because their body has grown and gotten larger muscularly, and the heart still has to work harder at providing a network of vessels and to those new muscles. So their heart still has to work harder, again, to support the big muscular body mass that they have added to their stature. So they shouldn't ignore the fact that there are some risk factors still involved, but it shouldn't be used alone. According to the BMI, I guess it's based off of height and weight. The one in your book is based on kilograms of body weight to how tall you are in meters squared. And in order to convert your body weight in pounds to kilograms, you divide it by 2.2. So if you weigh like 150 pounds, divide 150 by 2.2, and that's how much you weigh in kilograms. Now, according to the BMI, and again, these charts are abundantly available online. Also, your book has one, but based on your height and weight, a healthy weight on the BMI is considered if you're between 18.5 and 24.9. Now, as you go higher, you can also be considered overweight, but anything above 30 is considered obese. It does not assess body composition, however, so it doesn't tell you how much fat and muscle you have. Also in kinesiology, we say it doesn't tell you how much fat-free mass you have, which is muscle, bones, and organ weight versus your fat tissue. So again, it's not, some athletes will ignore it, but I let my athletes know that it's part of one of their many assessment tools that we use to assess them, but it's not used alone. And also ethnicity. So certain ethnicities are just staturally bigger or smaller than others. And there's been some debate about how that can be judgmental. So here's a BMI table. So it's letting you know that based on your height on the left side. So like I'm 5'3", and I just had a baby a few months ago. So I'm still trying to lose my weight and get to my pre-pregnancy weight, which was 137, which would put me in the healthy range. But right now I'm at 144. And according to my still postpartum body at 5'3" at 144, I'm considered overweight. So as your professor, I still, I have a baby that's a few months old. I'm still working on getting to my pre-pregnancy weight of 135, 137-ish, which puts me at a healthy weight. But again, I've had my body composition done before I was pregnant. And even though pre-pregnancy, I was at 135-ish, 137-ish, I was on the borderline. But according to my body composition test, I have a lot of muscle compared to fat, and it made me a little healthier. And all my blood tests are pretty healthy. So Again, having these overall assessments done gives you a better outlook of your health, but I should not ignore what the BMI is telling me because a lot of people in my family do tend to be short and very round, and we have diseases. Now for this slide, I meant to provide percentages here, but what I want you to focus on here is more of the BMI numbers. So I might ask you on the test, what is considered, Sally or Joe has this BMI, what are they considered? So a healthy weight is considered if you fall between 18.5 and 24.9 on the BMI. You're considered overweight if you have a BMI of 25 to 29.9. You're considered obese based on your height and weight if you are 30 to 39.9 on the BMI. And there is also a category of extreme obesity, and that's people who are greater than or equal to 40. We also have morbid obesity, which is on the higher ranges. Now, underweight is a BMI of less than 18.5. If I have an athlete, I do take BMIs a little bit with a grain of salt more than a regular person, only because based on the sport, their body composition can differ. But at the same time, I let them know that even though they play the sport and their body composition is as this and that there are still some risk factors that they should consider. Like I said, like the bodybuilder, he should still consider the risk factor that being obese on the BMI can also mean that it's hard on the heart, okay, because there is a bigger body there that the heart has to work with. Apple and pear body shapes, like this is just generality. So I'm not shaped like a pear. I'm a little bit more equal in stature. I tend to gain weight everywhere when I gain weight, not just in my lower body. But it's saying here that typically women have a pear-shaped, where the lower body fat is more common in women than men, and it's usually associated, not usually associated with chronic diseases because the fat in the lower body is considered less detrimental than the fat around the torso area. And that is because if you carry a lot of fat in the torso area, you can actually over time make straight deposits into the heart. So direct fat deposits. But again, we're not all pear-shaped. I'm one of those. But if you that is called gynoid fat. So if you ever heard of gynoid fat or gynoid shape, it's a pear-shaped. Men are considered more android-shaped or apple-shaped, and that means that they tend to carry more of their fat in their upper body, and it's more common in men than in women. It just is more common in men than in women, so women can have it and may be more closely associated with chronic diseases because of those direct fat deposits it can make into the heart. Now, as you see here, the image of the side image of this male, it is very, very, very vital to have fat around your organs. That is called visceral fat. Okay, that visceral fat protects the organs of the abdomen and also serves as a glue to keep your organs suspended together. Now on the further right, you see that this man has gained weight around the torso area, and in addition to his normal visceral fat, he's gained more fat around his organs, and that imposes a bigger risk of heart disease, okay, and heart attacks and stuff like that. So over time, if he continues like this, it can pose a threat to his heart. Now the fat around your organs is called visceral fat, and the fat directly underneath your skin is called subcutaneous fat. And visceral fat is considered more detrimental than subcutaneous fat because it's closer to the organs. So table 8.1 in your book has two calculations, one for men and one for women. And again, in order to carry out this calculation where it says weight, WT, you have to have your weight in kilograms. And the way you do that is you take your weight and divide it by 2.2, and that's how much you weigh in kilograms, okay? Now, if you are, and then height in centimeters. So keep in mind that's 2.54 centimeters in an inch, and then your age in years. So what I'm going to do is in addition to this lecture, I'm going to attach a document in which I carry out the calculations for you so you can see an example. So make sure you download that. So let's quiz ourselves again. You can read this and attempt to fill in the blanks, and then pause it and then come back to the answers. But here's the answers. A waist circumference greater than 40 inches for men and greater than 35 inches for women is an indicator of fat distribution and central obesity. So here's another assessment you can perform with BMI to determine health status. Explanation, waist circumference together with BMI are inexpensive. That's the good thing about girth measurements and BMI, that they're inexpensive, accessible tools. Easy to obtain and valuable in assessing a person's health risk. Waist circumference alone is the preferred method for assessing central obesity. Now, even though these are the easiest methods, I still encourage people to get as many health assessments done in order to determine their health status. For example, a lot of the armed forces use waist circumference and BMI to determine if a soldier is healthy and can be accepted into the program. I ran into a prior potential male who wanted to be part of the armed forces, and he was rejected even though he was this big bodybuilder because of the fact that he was considered too high on the BMI and considered to be at risk of certain things like a heart attack. And he said his friend was accepted, and his friend has a lot of belly fat and has a belly, just because the BMI said that, you know, he was at lower risk based on his height and weight. What the armed forces should also know is that even though his friend was accepted based on the BMI, carrying that extra amount of fat in his torso is still a potential risk factor physically. Okay. So here are some common methods used to assess body fat. I'm only going to explain 3, and I want you guys to read the rest in your book. So most likely I will test you on the 3 that I explained, but I might test you on the others just to make sure you're reading your book. So skin fold measures that you see here first. This one can be pretty accurate if the technician is skilled and experienced. What we do here is the technician will pinch the fat away from the muscle, and it can be very uncomfortable. It should be uncomfortable. And they will use a skin caliper to measure certain skin folds. And based on certain calculations, for instance, I used the American College of Sports Medicine during my undergrad. Some people use the National Strength and Conditioning Association recommendations, but based on the skin fold measurements that we get, we carry out calculations, and it tells us how much body fat and muscle mass this person has. And it can also be converted to pounds. The skin calipers have to be calibrated, so it's also how accurate and how up-to-date the tool is, and how if it's calibrated often, and the skills of the technician. Okay, I used to do 7 sites when I did this. There's a 3-site skin fold measure, and there's a 7-site. I used the 7-site even though it was more tedious, because when my clients were altering their body composition, I had more sites to determine where this change was happening. Hydrodensitometry, or hydrostatic weighing, we call it as well, measures body density by weighing the person first on land and then again while submerged in water. And then the difference between the person's actual weight and underwater provides a measure of the body's volume. And then a mathematical equation using the 2 measurements, volume and actual weight, determines body density, from which the percentage of body fat can be estimated. Another one is bioelectrical impedance. I actually have one of those devices, and I had planned to bring it to class and have you guys stay after class and use it, but with the transition we cannot do that anymore. But it is a device in which you enter your profile, like your height, your weight, your age, your sex, and then you hold on to these handles, and it measures body fat by using a low intensity electrical current that is run through your body. And because electrolyte containing fluids, which readily conduct an electrical current, are found primarily in lean body tissues like muscle, the leaner the person, the less resistance to the current. The measurement of electrical resistance is then used in a mathematical equation to estimate the percent of body fat. Okay, and some devices automatically do the calculation for you so that the person doesn't have to do it manually. Health risks associated with body weight and body fat. So body weight and fat distribution correlate with disease risk and life expectancy. Correlations are not causes. Again, when a disease is found in someone or diagnosed, diet can be a factor, but often diseases are a multitude of factors contribute to it, and it's complicated. So it can have to do with diet, physical inactivity, stress, ethnicity, genetic factors, any environmental factors like are you a smoker. So just know that a lot of diseases, even though there's correlations, it's not the direct or exact cause of that. Now, the risks associated with being underweight also means that you're not able to fight or ward off diseases. You can have menstrual irregularities and infertility, osteoporosis and bone fractures, and other things like you can be more susceptible to anemias and other like blood and organ disorders. So body mass index and mortality. So it's just showing you here that on the body mass index, whether you're underweight or overweight or obese, there are mortality rates associated with being very underweight and also very overweight. And as you go more into the normal range, they're seeing mortality decreases. For example, a risk factor of being obese on the BMI scale is that you're more susceptible to heart disease. Obesity is a designated disease. There are some health risks associated with it. For instance, you can be more prone to joint problems, organ failure, cell resistance. You're more likely to be disabled in later years. Costs medically can also be higher for you, and you can lose productivity as a result, and even be at risk of premature death. And research is showing that when you are obese, many of you have learned the way your cells function are altered in a negative way. So this last slide right here is still on obesity and specific disease risk factors. So cardiovascular disease, the relationship between obesity and cardiovascular disease is strong, with links, as you see here, to both elevated blood cholesterol and hypertension. Okay, now central obesity, as you see here, may raise the risk of heart attacks and stroke as much as the 3 leading risk factors, like the high LDL cholesterol, hypertension, and smoking do. Also, in addition to body fat, weight gain also increases the risk of cardiovascular disease. A little bit about diabetes, especially type 2, which is the one that is more considered lifestyle induced, even though there's some genetic predisposition as well. The incidence of diabetes has risen dramatically, you guys, in recent decades, and as the nation's population has grown more obese as well, so that tells you something. I want you to know that type 2 diabetes is far more likely to develop in an obese person than a non-obese person. Okay, and then central body fat or obesity cells appear to be larger and more insulin resistant than lower body fat cells. So the association between insulin resistance and obesity is pretty strong, and both are major risk factors for the development of type 2 diabetes. Okay, and then there's a little segment here about cancer, but both the duration and the severity of overweight or obesity increases the risk of developing some cancers and interferes with some treatments as well. Okay, one possible explanation can be that maybe that obese people have elevated levels of hormones that could influence cancer development. And here's an example: adipose tissue is the major site of estrogen synthesis in women. Obese women have elevated levels of estrogen, and estrogen has been implicated in the development of cancers of the female reproductive system, cancers that account for about half of all cancers in women. Another explanation, just so you know, may be that the chronic inflammation that accompanies obesity is a risk factor for several cancers. Okay.